Hello and welcome back. In the previous lesson, we have successfully authenticated user with wallet, and now in this lesson, let's interact with the smart contract. Now back in the HTML file, let's extend the UI by adding some interaction elements. Let's first create one div where we can create the store and read elements. This time I will directly copy the elements to save the time. The complete file and project are provided in the footnotes and you can copy from there as well. So let me explain this. This div is created for storing the number. From this input, the user will be able to add the number. And after clicking on this button, we will execute the function from JavaScript. I have added their IDs respectively. This div is created for reading the number. And after clicking on the button, we will execute the function to read the number from smart contract. Here in the span, we will print it out. Here also I have added their respective IDs. Now let's see how this looks. Okay, so we need to remove the hidden class from the DApp body. That's we have already added in the last lesson. And once removed, here you go. Our DApp looks beautiful. Now that the UI part is taken care of, we can go for building the respective JavaScript functions in the main.js file. Now back in the main.js file, in order to interact with the smart contract using the connects library, we need the contract ABI and its deployed contract address. Let's create a file abi.js and export the const variable named ABI. You can copy the contract ABI from remix ID. Now back to the remix ID where we have created the storage smart contract. Select the file, compile that file again, and then down here copy the ABI and let's paste it back to the abi.js file. Once this is done, next in the main.js file, let's import the ABI that we have just defined. We can do this using import ABI from ABI. Now we have ABI available in this main.js file. Now let's declare the contract address and save it in the variable const contract. Then we have to add this contract address here. So let's get it from the vChain Explorer. Remember, I have told you that you can get the contract address from Text Explorer. When you deploy the contract, go to the wallet and find the transaction and click on the Explorer, and here you can see that contract address is present. So copy this contract address and back in the main.js, paste it in front of the variable. So now we have both ABI and contract address available. Let's define the store function. So first let's get the store button declared in the HTML file, and we can do this as usual using the query selector and then passing the ID of that button here. And once this is initiated, we can add the onClick event to it. Also the function will be asynchronous. Okay, the async spelling is wrong. So here ASYNC, and that's correct. Now in this function, let's first check if the user is logged in or not. So we can do that by creating a new variable called user login here at the top above, and let's set it false by default. And in the login function here, when we got the response, we will change its value to true. Now back here in the condition, if the user is not logged in, then we will alert the user that please log in first. This is not needed as the user has to sign in anyways and then send the transaction. But as we kept our DApp flow working like this, like first the authentication and the interaction, that's why we are implementing it. Now here if the condition is true, let's get the value of the number from the input. This can be done by getting the element with query selector, and as this is the input and we just want the value out of it, the query selector will just get the instance of the element, and to get the value we have to add the dot value in front of it. Again we will add one more condition, like if the user number dot length is greater than 0, then perform something, otherwise we will alert the user to please add the number to the input. So this user number dot length, basically this condition will check if the user has clicked the button store without adding anything to the input. So at least one number should be present there, right? We can't store an empty input to the blockchain. Now this condition is also done, and now here in this condition we will get the ABI of the function. In order to interact with the function using connects library, we need to pass which function we are calling or wanting to interact with from the smart contract. So this is where the ABI comes into play. We will find the store function from the ABI and then store it in the variable called store ABI, and then we will use the store ABI variable later. Once we have specified which function we are going to interact with from the smart contract, let's create a clause. Now let me tell you something about this clause thing. A clause is essentially an object that instructs the smart contract on what to do. It contains all the necessary information for the smart contract to execute the function, such as which function to call or any additional requirements, etc. To execute a function from smart contract, you must create your own clause object and send it through the transaction. Then the smart contract will perform the necessary actions and execute the specified function with the provided parameters. It's that simple. The interesting fact is that you can create multiple clauses and pass them in a single transaction. So to explain it in a layman terms, you can think the clause as the instructions given to the connects library, or instructions that we are going to add in the transaction. Once we perform the transaction, we will definitely explore how the transaction looks like in the Explorer. We will discuss what are different parameters and how to read them. So moving forward, let's create our clause here. We need to define which contract we are using. So we are going to pass the contract address in this account method, so that the connects library will know to which contract we are going to interact. And then the function using method. Now the connects library knows which contract to interact with, but don't know which function to interact with. So we have to pass this in this method. We can pass any arguments to the function in the clause. If the function in the smart contract accepts multiple arguments, then they should be passed in an array. And this array will be passed in the as clause method. So that's it, we have defined our clause. Let's organize this information to make it more readable and aesthetically pleasing. Code should be always easy on the eyes, right? Now that our clause is defined, let's define the transaction object. This time we will use the vendor, and the first parameter will be transaction instead of sign, that's TX. The second parameter will be the list of clauses. Here you can pass multiple clauses, whether it be interacting with more than one function from a single contract, or multiple functions from multiple contracts, or even a raw transaction. This is the power of VChain. We cannot do this in Ethereum. Once you do this, we can pass the comment which will appear in the wallet when the user signs and sends the transaction. And lastly, we request it with .request. Done. You can add the alert at the end to know that the transaction is done. So I think this is it for this lesson. We will execute the store function and define and run the read function in the next lesson.